Here we are in chapter 6 now. So first we're going to talk about discrete and continuous random variables. So we have our probability models, which give us like all of our x values and then all of our probabilities. And each x value is just the random variable. So the random variable it's just going to tell us the values that it can take, and then the probability distribution gives us those values and the probabilities. So if you toss a coin 3 times, and if x is the number of heads obtained, so it's possible that you could get 0 heads, 1 head, 2 head, or 3 heads, these are the ways you could get it. So then they take those values and create it into a probability distribution. So those are the values, those are the respective probabilities. And then you can also make a histogram from that. So here's the values, and these are the probabilities. We have 2 main types. We have discrete and continuous. In this chapter, for the most part, we dealt with discrete ones. So discrete ones, they're just going to have, remember that value it's like a countable number, so there can't be anything in between. So it's going to be 1, 2, 3. Like with the head, I'm tossing the coin and getting a head. You can't have 1.5 heads. Like you have 1, 2, 3, 0, so on. Remember, all these probabilities satisfy 2 requirements. So each probability is a number between 0 and 1. It can be 0 or 1. And the sum of all those probabilities has to add up to 1. So in this one right here, just to show that it's legitimate, you would check here all the probabilities add up to 0 and 1, or all between 0 and 1, and they all add up to 1, so it's legitimate. You can create the histogram here of the probability distribution. When you create that histogram, you can draw some conclusions. So I can see these are APGAR scores, which is just how they evaluate a baby after he or she is born. And so the higher the score, the better. So most of those scores are high. Not a lot of babies get a score of 10. Most are 8 or 9. And then if I wanted to get a score of 7 or higher, so what I would do here is you would add up to 7, 8, 9, and 10. Also, just for that description here, so it's a left skewed, so like I said, most of the babies are down there. So if we have to analyze it, we'd follow the same strategy, so we'd still go back to our socks. So we could talk about the shapes, like in that last one we could say it was left skewed. We could say the center was, we can find the mean of this, and we can find the standard deviation, and we'll use those values. Outliers, I mean, you could maybe say some of these ones down here are outliers, but you could find it mathematically. So when we find the mean, basically, remember the mean, another way to think about the mean is calling it its expected value. So the mean is just what you expect. Remember, those 2 terms are interchangeable. So we're just going to take each value and multiply times their probability, and then we're going to add them all up. Remember that notation, so this is the mean of all the x's. There's no little bar there. Or you can write the e of x, like it's the expected value of x. So when we look at this score right here, so what we could do here is we could take each individual value and multiply it times its probability, and then add them all up, and you'd get that for an answer. I did show you an alternative way to do this. I showed you that you could do it on your calculator. So I have all these values already in my list. So I put my x's in list 1 and my probabilities in list 2. So I'm just going to go to Stat. I'm going to go over to Calculate. I'm going to use that 1var stats, and then I'm going to do that list 1, comma, list 2, and then press enter. And there's my mean right there, so 8.128. So again, you could do it doing the work, or you can just do it using the shortcut on the calculator. So then to interpret it here, they say the mean APGAR score of a randomly selected newborn is 8.128. So this is the long-term average score of many, many chosen babies. The expected value does not need to be a possible value or an integer. It's just a long-term average, so it's okay to not round it. Alright, we can also find the standard deviation. The formula here for the standard deviation was that we took each x value, we subtracted the mean, so the mean that we just found, we squared that, we multiplied times the probability, and then we added them all up. And then that's the variance. And to get the standard deviation, you'd always take the square root of the variance. So back to those APGAR scores. So again, we could take this minus the mean we found, square it, times the probability. And then this one, minus the mean we found, square it, times the probability. We could add all those up. That would give us our variance. We take the square root of that, and that would give us our standard deviation. But I did show you that you can do it in the calculator. The calculator, if you've done this correctly, this will be blank. And the calculator will give you the standard deviation. And when it gives you the standard deviation, if you wanted the variance, you would have to square it to find the variance. So the standard deviation is 1.43, so that means on average, a randomly selected baby's APGAR score will differ from the mean 8.12 by about 1.4 units. So it just gives us an idea on average how far away things are. So it's not too spread out. Most things are pretty close to that average. We also had continuous random variables. So continuous, they are not necessarily coming from counting, so they're not going to be a fixed number. Usually we describe continuous random variables with density curves. Still, when we are describing them with the density curve, the probability of any value could be between 0 and 1, including 0 and 1. Remember, there's infinitely many values. If I wanted to find the probability that I'm just equal to some number, that's always going to be 0 in a continuous distribution. Only intervals can we find probabilities for. An example of a continuous random variable is the normal distribution. So we can look here, this is the normal distribution, this notation right here, this is the mean, that's the standard deviation. So what's the probability? A chosen young woman's height has a height between 68 and 70 inches. So they shaded it here. They're going to go through and show you how to do it by converting it back to a z-score. And then they went back and they looked it up in the table. Remember, I showed you that you could just do it on the calculator. Just make sure that you write out like what you're finding the probability of. So we use the normal CDF command. The lower bound here is 68. The upper bound is 70. The mean is 64. And the standard deviation is 2.7. And there's my answer. It might be slightly different from theirs because they're using the chart and I'm using the calculator, which is much more accurate. So I would still have written out this statement. I would still draw my picture. All this stuff right here I would replace with my calculator command and my answer. And then if they were asked, I would still probably summarize it too on the AP exam. Alright, that's this first